Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's lesson on sequence and series, we're looking at converging geometric series and calculating the sum to infinity. It's that formula, so we're going to explain to you. In general, we have a saying, maths teachers converges to a point, mathematicians diverge, they find bigger problems that we didn't know exist and they solve them, right? So basic theory. A series in which the sum, Sn, of n terms of series tends to a definitive value, meaning as I'm adding and so on, I always end up going to a specific value and I'm not going to go past that value. Sn tends to infinity, meaning is termed as a convergent series. So meaning if I add things that's getting smaller and smaller, eventually it will not change the answer, and that is the answer. It will stay no matter how many terms I add after that. Right, then we're dealing with a converging series. Right, now, if Sn does not tend to a definitive value, meaning as I add more values, the answer either continues getting bigger and bigger and bigger, we say the series is said to be divergent. Right, now, arithmetic sequence, number one that we've worked with, or linear sequence, will always be divergent because as n tends to infinity, the sum to n also tends to infinity, meaning the more terms I add, the bigger the value will become and the more it will continue towards infinity. Right, now a geometric sequence where the value of r, very important, is less than 1 or bigger than minus 1. Right, so we're going to use this, take special note of it. So when r is less than 1, so it's 0.99 or half of 0.5, and bigger than negative 9, so it's negative 0.99, negative 0.5, negative half. Right, so if it's a fraction in between 1 and negative 1, then the series is considered a converging series. So converging series, yeah, take note, we're working with R, so we're working with a geometric sequence, right? We're going to use that even in the slides to follow and in the videos to follow to solve certain problems, all right? Now, when we say the sum to infinity of a geometric sequence, right, we first take in account that my geometric sequence is converging. If it's converging, my R is less than 1 greater than minus 1, then we will use this formula, sum to infinity equal a1 minus r. So that's just basic theory. All right. So if r is bigger than 1 or r is bigger than minus 1 or r greater than minus 1, r less than minus 1, r bigger than 1, then we say the series is diverging. It falls in between those two, it is converging. All right. Now, proving a series converges, so here we're given 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 6. So in general, you should see these fractions are decreasing, right? Now they said determine the common ratio. So when they say common ratio, automatically I assume we're dealing with a geometric sequence, right? And prove the series converges. So first R would be term 2 divided by term 1. So quarter divided by half. It's the same as saying a quarter, change division to multiplication, and that becomes 2 over 1. 2 goes in itself once, 2 goes in for 2 times. 1 times 1 stays 1, 1 times 2 becomes 2. So R for this sequence is half, and half is less than 1, bigger than minus 1, right? So for series to converge, R must always be less than 1, greater than minus 1. And if I put this R value there, half is smaller than 1, and half is bigger than minus 1. Therefore, the series converges. All right, let's look at the next problem. Determine the sum to infinity. All right, so for this sequence, the same one I worked in the previous, we already know that A is half and R equal 1 over 2, right? So sum to infinity equation will always read A divided by 1 minus R. A value is equal to half, R value is 1 minus half. 1 minus half gives me half, so I have half divided by half, which equals 1. If 1, 2 half times 2 over 1, 2 and 2 cancels, and I'm left with 1. Right, so there we determine the sum to infinity. Right, and there we solved R. So this is just some basic knowledge for you to know what you're going to do when a series converge and how we check if it's converging or not. In the next video, we're going to do some problems using this knowledge. Okay, God bless. Bye.